Now let's just take a minute to summarize what we've learned in this module before we move on to the next topic. If you don't have any of these things, if any of these things are missing from your notes, please write them down because they're very important. So in summary, a binomial experiment requires, 1, a fixed number of trials. It can't go on forever. Also, each trial must be independent of the other. So one trial happening cannot affect the next one. If it does, it's not a binomial experiment. Next, each trial has 2 possible outcomes called success or failure. They might not be called that, but there should only be 2 outcomes. What you're interested in happening and then that thing not happening. Also, there's a constant probability p of success for each trial, the complement of which is the probability of failure, 1 minus p. So probability cannot change as you go through these trials. It has to be the same. In binomial random experiments, the number of successes in n trials is random. It can be as low as 0 if all the trials end up in failure, or as high as n if all n trials end in success. The number x, capital X, of successes in a sample of size n taken without replacement from a population with proportion p of successes is approximately binomial with n and p as long as the sample size n is at most 10% of the population size, capital N. In symbols, this would be lowercase n is less than or equal to 0.10 times capital N. This is the same as saying the population size is greater than or equal to 10 times the sample size. In symbols, this is capital N greater than or equal to 10 times lowercase n. The mean of a binomial random variable, capital X, with parameters n and p is n times p. If x is binomial with parameters n and p, then the standard deviation for a binomial random variable, capital X, is this little formula here. So we have these 2 formulas we saw on a previous page.